Okay, let's try this. So we've taught ionic bonds, where the electrons are transferred. And we taught covalent bonds, where the electrons are shared. Well, there is a combo or combination of the two, which is polyatomic ions. So basically, if something looks weird, has 3 or more elements in it, and by looks weird, I'm saying its name ends in like 8 or "ite," it's got more than 3 elements, then you're going to check your list of polyatomic ions that I'll be giving you and see if that's where this happens to be when we go to look and name them and figure out what they are. Okay, next slide. All right, polyatomic ions are composed of 2 or more covalently bonded ions that act as one large atom. They basically act as one big ion. I don't know where that page is. Okay, good. So if they end in 8 or "ite," that usually means it's going to be one of these combo things, which is a polyatomic ion. All right, so polyatomic ions bond just like any other ionic compound, except you don't know their specific names yet because I haven't given you the list. So when naming polyatomic ions, you're going to find the specific sequence of capital letters in your chart. When I'll be giving you or showing you, there's actually several. Then you write the name straight from the chart as we start to name these things. Here's a list of polyatomic ions. You'll get more later. But see how we got sulfite, sulfate. Sulfate has a -2 charge, but has 1 sulfur, 4 oxygens in it. Sulfite has a -2 charge, but it has 1 sulfur, 3 oxygens. So this little chunk acts like one ion and then would bond to something else. So we could have calcium, which has a +2 charge, bonded to SO3, which has a -2 charge. Those two would balance each other out, so it'd just be CaSO3, and that'd be called calcium sulfite. So it's kind of like one of those things where you find your Jedi name or your wizard name or whatever it is, those little things on the internet that you play with. Now, when I converted this, it turned out a little strange here. The numbers didn't line up exactly where I wanted them. So we're going to go back 1 slide. So this PO4 to 4 should be here. So PO4 is somewhere on here. I'm blind. Phosphate. So PO4 has a -3 charge. So when we look at this, K3O4, well, potassium we know is in the first column, so it should have a +1 charge. And this PO4 is that phosphate ion that had a -3 charge, which is why it takes 3 potassiums to balance out one of these. All right, so this is magnesium nitrite or nitrate, depending which one it happened to have been on that. So NO3 is nitrate. It's got a -1 charge. So magnesium, we know, has a +2 charge from our colored periodic table we did. And this nitrate is NO3. It has a -1 charge. So 2 times -1 is going to be a -2. This potassium has a +2. So that's why Mg balances out with NO3 and 2 of them. This is ammonium chloride. So ammonium's got a +1 charge. Chloride has a -1 charge. That's why that sticks together. Polyatomic. So these two, this little section is joined together covalently. And then the whole thing sticks together ionically. So it's a polyatomic ion in an ionic bond. So polyatomic ions act just like an ionic compound. Each polyatomic ion has a specific oxidation number. You find it on the chart and you crisscross them. So what was that? PO4 had a -3 charge, and whatever you're trying to hook it up with, say, I don't know, sodium. Sodium has a +1 charge, so you crisscross those, so you're going to need 3 sodiums to every 1 phosphate. So it end up being NaPO4 and 3 sodiums. So Na3PO4. Does that make sense? I know you can't answer me. That's rhetorical. Okay, so sodium carbonate. Carbonate is, let me pull out my handy dandy list of polyatomic ions, and we'll find carbonate as soon as I find it here. Sorry for the pause and the delay. Carbonate is CO3 and it's got a -2 charge. Oops, I got it right on the right tablet. So CO3 and carbonate has a -2 charge. Well, sodium we know is Na. It has a +1 charge. So to get the full compound for this, it'd be Na2. So we crisscross those charges. CO3, and there's just one of them, so we leave that blank. Barium is Ba. It has a +2 charge. And nitrate is, I want to say it's NO3. Nitrate is NO3 and it's got a -1 charge. Whoops. NO3, it's got a -1 charge. So to put all this all together, it's going to be BaNO3. And since we need 2 of those to balance out that barium. So barium nitrate's formula looks like that. Ammonium is NH4. This has a +1 charge. Sulfate, so this is 2 polyatomic ions bound together. So the sulfate ion is SO4, and it has a -2 charge, so we're going to need 2 ammoniums to balance out 1 sulfate. So the equation for this thing would be NH4, we need 2 of them, and then SO4. Alright, so hopefully that makes sense, and we'll go over some more of that later. But this is my first attempt at a screencast, so let me know if it worked and made sense.